Very good evening. This is Morgan, Assistant Professor, Department of Agriculture Engineering, Sri Shanmuga College of Engineering and Technology. So today we're going to discuss about the topic Introduction to Bricks and Cement. In the last session, we had a great discussion about stone, what is stone, how it has been extracted, what are the criteria that would be selected for stone, what is the good qualities that has been for stone, preservation techniques, deteriorations, causes and effects, and what are the tests that should be carried out for stones that we have discussed on last session. And this session we're going to discuss about another construction material called cement, and also we are using the most important binding material will make the two things to be joined together as cement. Types of brick: building bricks, heavy duty building bricks, perforated building bricks, hollow bricks, facing bricks, paving bricks, soling bricks, specially shaped bricks, fire clay or refractory bricks. So these are some classifications of bricks which we using in one of the construction materials. So we have the comparison between the fly ash. Here in the 70% of fly ash as one of the main ingredient for making this brick. The second one is normal red clay bricks, which has been widely used in all the construction practices. Here we have a major differences between these two. Normal red clay, varying color as per the soil, because the red color indicates about the soil colors. It has determining the color, determining the major factor. Here the fly ash, uniformly pleasing color as like cement. Here uneven shape, if it is made up of handmade, now it is completely even shape, which because of the mold, everything is in uniform shape and size. Here in case of fly ash, uniforms in shape and smooth in finish. In normal clay bricks, it is a lightly bonded. Here dense composition. Here plastering is required. Here no plastering is required. The shape itself, it doesn't have any required finishing. Here heavier in weight, lighter in weight. Here the minimum compressive strength comes around 35 kg per centimeter square. Here it comes around 100 kg per centimeter square. Here is more porous, here is less porous. Thermal conductivity varies from 1.25 to 1.35. Here thermal conductivity varies from 0.9 to 1.05. Water absorption varies from 20 to 25%. Here the water absorption varies from 6 to 12%. Here the properties of red clay as well as fly ash. The density, it varies from 6,600 to 1,750 kg per meter cube. As in the case of fly ash brick, 1,700 to 1,850. It has been used for higher load resistant structures. Compressive strength 30 to 35 kg per centimeter square. As in the case of red brick, fly ash brick 100 to 90 to 100. Same it is for the high load bearing structures. Absorption 15 to 25%, 10 to 14% in fly ash. It has less dampness. Dimensional stability, it has very tolerance. Here it is having high tolerance, saving your mortar up to 25%. Wastage during transit up to 10%. It is less than 2% because of saving your cost from 8%. Plastering thickness vary on both sides of the wall, even on both sides. So we have the plastering is reduced up to 15%. Here this is the manufacturing of bricks, how it has been manufactured. We just extract the corresponding clay or soil from the mining. We have to be stored and have to be reduce the size. If there is size is more than 4.75 mm, we have to be reduce the size by using of size reduction machine. Then screening, we have to save the size, the finest particle that has to be used to make the binding very properly. Then forming and cutting by using of different molds with the respective dimensions. Then coating and glazing, if it's required, we'll go with the coating, coating on the top surface of the brick because of the overcome from the water absorption. Then it has been stored for drying. Then if it is any fire resisting properties that you have to go for, let me go with the firing and cooling, then storage and shipping. So here that we can say red clay bricks are burnt lead clay bricks that has been used in the market now. So these are the manufacturing process: clay digger, roller, sand and water to mix up a mold, then drying in oven, moderate, high and cooling chamber. Let come for the packaging. So the properties of good building bricks: They're based on the color, shape, texture, size, sound, hardness, strength, water absorption, efflorescence, thermal conductivity, sound insulation, fire resistance. See, these are the some common properties of bricks. Based on that value, we can able to suggest that brick is good for using in construction. The test for clay bricks, let me go with the compressive strength of clay as well as water absorption. This is a special brick which has been used for construction for the aesthetic appearance. Specially shaped bricks that has been used for pavement. Burnt clay facing bricks for the front view of the building. It has gives a rich appearance. Heavy duty bricks, it has used for roads and pavements. Perforated bricks, it is in drainage system. Sand line bricks, sewer bricks, acid resistance bricks. So these are the some common special type of bricks which has been used. This is about the refractory. This is about the cement concrete blocks. Next one is the major ingredient which has been used in manufacturing of brick is about the lime. It is a preheating limestone which has more or less pure calcium carbonate. During heating, the carbon dioxide is driven off and non-volatile impurities such as oxides of silica, magnesia, aluminium, iron, manganese are left behind in lime, through which this lime is sometimes called as calcium oxide. So when we adding the lime is up to 5 to 7% in manufacturing of bricks. Why this lime is specifically added at this percent of 5 to 7? It has given better bonding to make the mold. So next is another important material which has been used in construction to make those elements like brick or even stones are as a rigid one. We are using cement. Cement is a general sense. It is adhesive as well as a cohesive material which are capable of binding together particles of solid matter into a compact durable mass. For a civil engineering works, they are restricted to calcareous cement containing compound of lime as their chief constituents. Its primary function is being to find the fine and coarse particles together. Fine is a sand, coarse is a normal gravels or stones. There are two basic components or ingredients present in cement. One is argillaceous and calcareous. So ingredient of cement, in ordinary Portland cement, we have two categories of cements are there. One is ordinary and then Portland pozzolanic, that is PPC, OPC. Maximum we are going with OPC. Now the recent trend that I have been using with some cementitious material to be incorporated into the cement manufacturing. So PPC are used for especially plastering or making the structural structures. We are using OPC. It contains two basic ingredients normally. Argillaceous and calcareous. In argillaceous, clay predominant. In calcareous, and the calcium carbonate predominant. Good ordinary cement contains the following ingredient. The lime contains 62%, silica contains 22%, alumina contains 5%, calcium sulfate 4, iron oxide 3, magnesia 2, sulfur 1, alkalis 1. So the major ingredients of cements and its function. Lime, already we have discussed. It's a huge proportions we has to be used, 72%. It makes the cement to be soundness and causes the cement to expand and disintegrate if it is in excess. And if the lime is in very less content, if you are in manufacturing of cement, the strength of the cement is decreased and causes cement to set very early. The same way is also gypsum. Silica, this is also important ingredient of cement. It gives or impart quick setting property to impart strength to cement. Alumina, this ingredients impart quick setting properly to the cement and weakens the cement property very early. Calcium sulfate, it is in the form of gypsum. Its major function is to increase the initial setting time of cement. Magnesia, it imparts hardness and color to the cement. That grayish color, it comes from the amount of magnesia available in the cement. Sulfur, it is useful making the cement to be very sound. If it in excess, the cement becomes unsound because the cracking effect is more if the sulfur content is maximum. Alkalis, most of the alkalis present in raw material and carried away from the flue gases during heating and cooling, very only small quantity will be left over. If it is in excess, the white patches will be formed when we dip into water for any water absorption test. So this is all about the construction materials like cement, lime and bricks. The remaining topics we'll discuss on the further sessions. Thank you.